These are the solutions for chapter 5.2 written homework textbook problems. First questions we're looking at are problems 21 through 24. They involve the same scenario. I've included here, you can see briefly, this is also in the formula sheet, in notes, and in the book. The formulas we use for chapter 5.2, which includes the addition rule, and that involves when we have situations where it says or. And so let's start first with kind of a straightforward probability. Let's start with a kind of a straightforward probability problems 21 through 24 using those formulas there. And so the difference in those formulas, again, they both involve or. If you look carefully here, probability of E or F occurring. One of them is for what's called disjoint events, meaning that the events have no overlap, that they can't happen at the same time. When we use the general addition rule, we have this extra piece here when events can happen at the same time. We have to subtract out that probability. So we'll see where that occurs. So in the first one of 21, we're looking for the probability that I'm going to abbreviate, that you have a Titleist or a max fly. And so the way I think about it in terms of you're going to apply this to the formula, probability of E or F equals the probability of E happening plus the probability of F happening. You add those separately. And so being able to select a Titleist or a maxi fly can't happen at the same time, so we don't have to worry about this issue. You can't select both those balls at the same time. It's one or the other, so we don't have an AND event to worry about. So these would be disjoint events, selecting a Titleist or maximum. So in this case, this is like your E, and this is like your F. So in terms of that, you're really calculating the probability of getting a Titleist plus the probability of getting a max fly. And so that's the way you're going to look at these first ones, E and F. And then you just go ahead and substitute to find out those calculations. What are the calculations? And so in this case, the probability of a Titleist, you have 9 Titleists, and in total there are 1720 golf balls. So this is 9 out of 20, plus the probability of a max fly, which is 8 out of 20. So the probability in this case is just going to be 17 out of 20. And remember, probability can be a fraction, a decimal between 0 or 1, decimal between 0 and 1, or sometimes a percent. So that's for 21. Let's go ahead and look at 22, see if I can squeeze it in here. 22, the probability of a max or a top flight. That's an OR problem. So we're looking at this one over here. And again, you can't choose both at the same time. So that's why we have to worry about this AND situation over here. So it's really just the probability of the max plus the probability of a top flight. And so in this case, this is going to be 8 out of 20. Max is 8 plus top flight 3 out of 20. So you end up with 11 out of 20 there. And so there's our solution for 22. Let's go ahead and look at 23. See if I can squeeze some more space in here. 23. Trying to get some space. Where could I do this? I guess not. Oh, there we go. And so now I have some space. So let's look at 23. 23. I'm going to start abbreviating a little bit more. 23. Probability of not a Titleist. So this is kind of going to be what's called the complement. I'm looking for everything not. So what is the not? There's 2 ways to think about it. Not Titleist. That means there are 8 and 3. There's 11 that are not Titleists. And so in this case, this is the same, technically saying the probability of not Titleist is the same thing as probability of max or top flight. So in this case, it really is just going to be what we have on problem 22, 11 out of 20. 11 out of 20. It's a 20 there too. 11 out of 20. The other way we could have seen that was 1 minus 11, sorry, 1 minus how many Titleists we have. This was another way to see this with an or here. We could have just solved that as 1 minus, how many Titleists do we have? 9 out of 20, and that's 11 out of 20. So that's 23. And then looking at problem number 24, right here, what's the probability of not top flight? So the probability of not a top flight is just going to be, I can do multiplies 1 minus the probability of a top flight, or I can basically say how many are not top flight. There's 9 plus 8, so the your answer is going to be 17 out of 20. In this case, again, the other way we could have solved this was saying 1 minus 3 out of 20, because top flight, there's 3 of them. So you have 17 out of 20. That's problems 21 through 24. Okay, this is video, well, the continuing of, this is problem number 25 from homework 5.2. Again, we're going to use some combination of these formulas to answer these questions here. So let's go ahead and get started. The following probability model adds up to 1, different probabilities, shows the distribution of murders by type of weapon for murder cases. And so this is the percent or the probability that the murder occurred with these weapons. Verify this is a probability model. To verify it's a probability model, it's real simple. When you add this up, the total equals 1. So we're good there. And each of these values is a value between, each is between 0 and 1. So that's a probability model ready to go. Part B. What is the probability that are randomly selected? So let's squeeze this stuff. Probability that if a randomly selected murder resulted from a rifle or a shotgun. Rifle or shotgun. And so those can't happen at the same time. A rifle, having a murder with a rifle, that same murder with a rifle and a shotgun can happen at the same time. So we're going to be using we're going to be using this rule right here. And so in that case, the answer is just going to be, I'm going to do it one more time, probability of the rifle plus the probability of the shotgun. So in this case, probability of rifle is 0.023, probability of shotgun 0.025. So when we put those values together, the answer is 0.048. What does that mean? That means it's very unlikely that you're going to have a murder with one of those because it's such a small value. So that's where that's what the interpretation would be. This is a very small value, meaning that it's not likely to occur. Part C. What is the probability that a randomly selected murder resulted from a handgun? Probability that it resulted from a handgun or a rifle or a shotgun. So there's 3 of them together. We come back to here, we're looking at one of these. All these can't happen at the same time, so just add up those probabilities. So in this case, the probability of a handgun is 0.472. I'm starting to abbreviate, I'm not going to write all this out now. Plus the rifle, which is 0.023, plus the shotgun, 0.025. So the probability that a murder happens with a handgun or rifle or shotgun is going to be the sum of that, and so that gives you, it looks like approximately 0.52. If I get that right, 0.52. Let's go to D. Probability that a random selected murder resulted from a weapon other than a firearm. So which ones are other than a firearm? So we want not a firearm. which is the same as the probability of what's not a firearm? That would be knives. So it's going to be these three here. And so that would be the probability the knives or hands or other. So you're just going to add up those probabilities. And so your answer would be 0.122 plus 0.056 plus 132. So the probability of all that together should be about 0.31. Okay, and then E, probability selected rather than the firearm, interpret this probability. So that means there's a 31% chance that someone would be murdered with that's not a firearm there. And then part E, are murders with shotguns unusual? The probability of dying from or getting murdered with a shotgun is equal to 0.25. So this is unusual. Why? Because 0.025 is smaller than 5%. There's problem number 25. This is problem number 40 now from homework 5.2, textbook problems. This is the first one now where we're going to have to then implement this formula here, where we're going to have to subtract out. There's these events are not disjoint, meaning that there is some overlap in some of these situations, and so we'll take a look at that. So let's start at the top here. So let's start with A. What is the probability that for a married couple selected at random, both spouses work? So here's the both spouses area right here. And so it looks like this row here has 1164. So the probability that both work is just going to be 1149 over 1700. And so you can turn that to a decimal if you like, or leave it as a fraction. If you're going to go to decimal, it's 0.676. Let's go ahead and go with B now. What is the probability that for a married couple selected at random, the couple has one child under the age of 18? So here's the one child. So these questions are back to chapter 5.1. And so we're just looking at real simple events. And so we're going to look at all this total. The probability with one child is equal to 353 over 1700, because that's the total amount of people. 353 have one child, and so the answer to that should be 0.208. Let's go to C. Looking at C, what is the probability that for a married couple selected at random, the couple has two or more children under the age and both spouses work? So this is a unique situation here where it's asking, what's the probability that both of these things occur? And so I can see this in the table. How many? The couple has two or more children. So this is two or more children right here. And both spouses work. And so here's both spouses work. And so the and means where is their overlap? It's like a Venn diagram. And so the overlap is 370. And so in this case, the probability of two children and both work is going to be equal to 370 over 1700. And so the answer to that question, 0.218. Again, there's an overlap in that situation. That's what's an important distinction between that problem. The and signifies that both conditions have to be true, and that's only 370 people. Part D, what is the probability for a married couple selecting at random? The couple has no children. Probability, no children, no child, or husband only. So that's an or situation, and in this case we're going to have to apply this formula here because we have this situation, the and has some value, And so in this case, if I was going to rewrite this, what does this look like, the whole formula? This is saying the probability of no child plus the probability of husband only minus the probability of no child and husband only. So that's the way the formula looks. And so then we need to calculate those values. Let me see if I can zoom in better. There we go. Let's calculate the values here. And so what we're looking at here is, what's the probability of no children? No children is here, so that's 788 over 1700 plus husband only. Husband only is across the top. That's 425 over 1700 minus the probability of no child and husband only. So I'm going to have to erase some of this. No child is here, husband only is here, so there's the overlap of no children and husband only, minus 172 over 1700. When you do the calculations for that, you should get 0.612. And then the last question would be unusual for a married couple selected at random for them to which only the wife works. And so part E, the probability only the wife works. Looking here, only the wife works is 126 over 1700, and this value is less than this value. Oh yeah, what is that value? So let's see. So let's cancel that out. Cancel. So doing the calculations on that one here real quick. 126 divided by 1700 equals 0.07. So I better erase that. I looked, that was going to be smaller than 5%. It isn't. This is equal to 0.074. So this is not unusual. Why is that? Because this is bigger than 5%. 0.074 is bigger than 0.05. That's it.